To most, the sun is nothing more than a ball of hot gas that heats the earth, a cheap way to get a tan, or maybe even a symbol of worship. But, my friends, the sun is more than that. It's a place full of activity, dynamic systems that science has only recently begun to understand, a place of wonder and bizarre things. And you will learn that you need to pay closer attention to our most important neighbor. Come with me as we journey to the sun. To start, the sun is a massive ball of superheated gas called plasma. The main gases include hydrogen and helium. The sun is about 409 times the size of the Earth, and at its center burns a core that reaches 13,600,000 degrees Kelvin, or about 2.5 million degrees Fahrenheit. Yet at the surface, the sun is only about 6,000 degrees Kelvin, or about 11,000 degrees Fahrenheit. But look up, the atmosphere burns at 1,200,000 degrees Kelvin, or about 22 million degrees Fahrenheit. It's kind of weird, huh? The sun sits at 93 million miles away, and it takes approximately 11.5 minutes for its light to reach us. So if you look at the sun, and I suggest you don't, you will actually see the sun as it was 11 minutes ago. The sun has many features, including sunspots, flares, CMEs or coronal mass ejections, columns, sunquakes, loops, and many others. But I'll be focusing more on sunspots and coronal mass ejections. Sunspots are formed when the sun's magnetic field becomes entangled within itself. The result is gases that are rising from within the sun and are diverted back or reflected to other parts of the sun. The spot begins to cool from lack of new energy, resulting in a darker area called a sunspot. When there are few sunspots, that is known as a solar minimum. When there are many, that is called a solar maximum. The switch between the two is called the sunspot cycle, and it repeats every 11 years. When there are lots of sunspots, that spells trouble. When there are sunspots, CMEs, or coronal mass ejections, are not far behind. CMEs, or coronal mass ejections, are when large portions of the sun's atmosphere are flung out into space. Most of the time, they are no threat to us, but if one hits the Earth, that is trouble. CMEs, or coronal mass ejections, form when the portions of the sun's magnetic field start to become entangled. A lot like a sunspot, but with CMEs, the magnetic line will become so tangled they snap. The snap acts like a catapult. Any gas riding the magnetic line, when it snaps, is flung out into space. They will fly through space near the speed of light until it hits something or disperses. Most of the time they miss the Earth, but it's serious if it does hit Earth. Most of the time, the only thing that the Earth sees from the sun is light, heat, and the solar wind. The solar wind is a low-pressure ionized gas that streams from the sun. It causes the Earth's magnetic field to warp slightly, forming a kind of an egg shape, and occasionally producing the aurora, or the aurora borealis. A CME, coronal mass ejection, is like the solar wind, but is much more powerful. When it hits, it peels the Earth's magnetic field like an onion, causing major magnetic disturbances that can short out electrical systems and leave whole areas of the Earth without power. It can also short out satellites, causing them to malfunction, and can actually make the Earth's atmosphere grow in size, causing low-orbit satellites to fall in and burn up on entry. During this time, the auroras will go crazy, as huge amounts of energy enter the upper atmosphere, causing it to glow like neon lights. Most recent CME, coronal mass ejection, was an event in 1989, which is known as the 1989 blackout, since a CME caused the entire Northeast America power grid to fail, leaving hundreds of millions without power. The sun doesn't only affect Earth, mind you. There are two other planets that the sun has impacted in a major way. Mercury, back when the solar system was young, had an atmosphere, but due to its closeness to the sun and a lack of proper magnetic field, Mercury soon lost its atmosphere, as the sun's solar wind stripped it from the young planet. For about 500,000 years, you could have stood on Earth's surface and watched as Mercury lost its atmosphere, a perpetual comet that never seemed to go away for long. The sun has also affected Mars in a similar way. Mars, too, early on, had an atmosphere, but a proper magnetic field to protect it as well. Mars had extensive oceans that were primed for life, but for whatever reason, the magnetic field began to fail. As it did, the atmosphere slowly went with it. Without an atmosphere, the surface water vaporized, leaving Mars cold and dry as it is seen today. Our sun has been conducting its cosmic alchemy since its birth, 4.6 billion years ago, processing a phenomenal 600 million metric tons of hydrogen every second. But there is no need for alarms for their start over 1, 2, 3. Our sun has been conducting its cosmic alchemy since its birth 4.6 billion years ago, processing a phenomenal 600 million metric tons of hydrogen every second. But there is no need for alarm, for there is enough hydrogen still left in the core to keep the sun shining steadily for about another 6 billion years. You see, the sun is more than just a ball of gas sitting in the sky. It's an important part of the solar system. We must pay more attention to it and give some respect, for the sun not only brings life and peace, but can bring chaos and destruction.